Hello. I would like to make some comments about claims made by Professor Lawrence Krauss during his public talks. I am a theoretical physicist who has contributed to the pioneering works done during the second half of the 70s on quantum field theory in curved space-time. My work was published in the most prestigious journals, the Physical Review and the Institute of Physics journals, and some of my papers are still in citation until now. As a general remark, I should say that Dr. Krauss overlooks some necessary details in the story of the creation and development of the universe. He also confuses some fundamental concepts of physics in his presentations. In addition to this, some of his claims are fallacious. The first confusion that I can spot is the mixing between laws of nature and laws of physics. Incidentally, not only Dr. Krauss makes such a confusion, but also Paul Davies, for example, and even Stephen Hawking. Davies says, for example, given the laws of physics, the universe can create itself spontaneously without the need for a creator. While Krauss says,
science has demonstrated, and I obviously don't have time to do an adequate job here, that the creation of a universe full of matter from no universe at all is not only plausible, but likely, and requires no supernatural shenanigans. Okay?
this claim is simply not true. Science has demonstrated that a universe can be brought into being from nothing if a sudden curvature is introduced into an otherwise empty space-time. Empty space-time is flat. But once gravity is introduced, it gets curved, and immediately vacuum energy and consequently matter get created.
Tell us that it's a boiling, bubbling brew of virtual particles. When you have gravity in, it means if you wait long enough, empty space with nothing in it can start to produce particles. It won't violate any laws of physics, but it gets better. Because when you allow quantum mechanics and gravity to come together, that allows then space and time, which are the dynamical variables of general relativity, if they become quantized, then they start to fluctuate too.
If nothing needs no creator, just because it is nothing, where does gravity comes from? Physics has no answer. In the second half of the 70s, we have formulated this problem, and we have always assumed a curved space-time, and we calculate the vacuum expectation value of the energy momentum tensor. The time-time component of this energy momentum tensor is the energy density, which is called the Casimir energy density. Without having a curvature, you cannot create vacuum energy. In a flat space-time, the vacuum energy is zero. Krauss says that the total gravitational energy of every object in a flat universe is zero. This statement is indeed obscure. For what it means to have an object in a flat universe. Once a massive object is introduced into the space-time, it will produce a curvature, certainly. Matter tells space-time how it would curve. But if no matter has been created as yet, how can we talk about gravitational energy and objects? See the fallacy? This is a contradiction. Krauss says gravity plus quantum mechanics allows space and possibly time to appear from nothing. In fact, Professor Krauss is bargaining on the fact that the total energy of our universe is zero. But even so, this by no means is an evidence that there were no creation or that the universe must have created itself. Krauss sometimes argues that the creation means adding something to nothing. And since God had added nothing, therefore he is not a creator. The vacuum energy, as I said, of a flat space-time is zero. No energy can be created without the introduction of gravity in the form of a space-time curvature. So it's not necessary for the creator to introduce matter or energy, to add matter or energy. A sudden curvature in a flat space-time will produce energy and matter. And, by the way, will cause the space-time to expand immediately. As the universe expands, as the space-time expands, what happens is that it gets flatter and flatter. And this is how the universe became flat after the huge cosmic inflation. Stephen Hawking previously used the argument of no beginning when he found that the universe could have been existing in an endless imaginary time. So he questioned the role of the creator and found that the creator is therefore redundant. Then he may have realized that the imaginary time is not measurable, is not a physical quantity. Therefore, no physical universe could exist in such a state. The role of the creator at the first moment, therefore, remains necessary. In a broader scope, there are some important facts that Lawrence Krauss overlooks when presenting science in show business. This way of dealing with the facts is causing a lot of confusion and misguidance on the part of the public. In many cases, mixing between the terms laws of nature and laws of physics is very common. This has to be clarified so that people know what we are talking about. For this reason, I should state the following. The laws of nature are the phenomena that takes place without any specification of the reason why it happens, other than being regular event. Like, for example, the free fall of a body, of a stone. Whereas the laws of physics are our own description of the laws of nature. They are our own interpretations, or, in other words, our own comprehension of the natural phenomena, set in terms of a well-defined statements or mathematical equations. Quantum mechanics tells us that events in nature are probabilistic. Therefore, laws of nature are indeterministic, while the laws of physics remains to be deterministic, differential equations. Consequently, laws of nature cannot take action by themselves, as they need to be set in operation by some agency, say a law of physics, for example. But since the laws of physics themselves are only our description of the phenomena, and they may change, by the way, during the development of our knowledge, as it happened with the Newtonian gravity, when Einstein discovered different thing. Therefore, laws of physics cannot actually operate the laws of nature either. Although some people may continue saying so dogmatically. Therefore, some agency is surely needed to run the laws of physics. Call it God or anything else. Coming back to the question of spontaneous creation of the universe, I should stress the fact that the virtual particle-antiparticle pairs of the quantum vacuum cannot be converted into real particles without the presence of external field of force. In this case, it is the gravity, or in a better description, we will say it's the curvature of the space-time, which is representing that field of force. Then if we say, for the sake of the argument, that the vacuum needs no creator, because nothing, who created gravity? Who brought gravity into action? To be a decent scientist, I should say I don't know. And I should not speculate and jump to senseless conclusions about the redundancy of God, since this is an unsolved problem in physics. The other point of argument is the claim that given the laws of physics, the universe can create itself out of nothing. Okay. This claim requires that the laws of physics exist before the existence of the universe, which cannot be the case. There is no arena for the operation of such laws. And second, the laws of physics on their own, they have to be qualified to operate the natural phenomena. But this, as I showed before, it's invalid. Laws of physics cannot operate a phenomena. They describe the phenomena. They describe the relation between the variables of the phenomena, but they cannot create the phenomena itself. They cannot drive the phenomena itself. Consequently, to be in operation, the laws of nature need some sort of a drive. Such a drive cannot be part of our universe, because should it be so, it will need a drive itself again, and this will continue in infinite regression. Thus, such a drive has to be external, not belonging to our universe. And this is what we find, or we call, transcendental. An entity which is beyond space and time and matter. An entity which cannot be described as simple or complex. Nobody can claim that the question, for example, of natural causality is solved. Since the time of Al-Ghazali and David Hume, causality remains as a pending question that has been even deepened. The problem has been even deepened by the discovery of quantum mechanics. So how can we say that laws of physics are doing the job, or laws of nature are doing the job of transformation or changes in the world? How can we talk with such a confidence as Krauss and Dawkins are showing about the argument of a redundant God? How can we explain the events in an indeterministic world? We ought to be more modest and stop this nonsense.
Okay. And the laws of physics are cruel, is bad. But instead, we should celebrate that we are not subject to the rules of some Saddam Hussein in the sky, who doesn't just punish people he doesn't like for their lifetime, but decides to punish them for all eternity. Instead, we should celebrate that we can make our own mistakes, we can make our own worth, we can make our own meaning, and we can make every second we breathe more worthwhile by enjoying the wonder of the universe in which we live. Thank you very much.
Aha, Saddam Hussein again. This is an example of the misguidance that Lawrence Krauss is celebrating. Now, after 13 years of the immense suffering by the Iraqi people caused by the destruction of their country under the excuse of getting rid of the tyranny of Saddam Hussein and the false claim of his weapons of mass destruction, comes a scientist like Lawrence Krauss to give an excuse for that crime. What a shame.